So chapter 6, lesson 4, completing the square. So what you're going to learn about today is solving quadratic equations by using the square root property and solving quadratic equations by completing the square. So some vocabulary to keep in mind are: what is completing the square? So how can you find the time it takes an accelerating race car to reach the finish line? So under a yellow caution flag, car race drivers slow to a speed of 60 miles per hour. When the green flag is waved, the drivers can increase their speed. Suppose the driver of one car is 500 feet from the finish line. If the driver accelerates at a constant rate of 8 feet per second squared, the equation t squared plus 22t plus 121 equals 246 represents the time t it takes the driver to reach this line. To solve this equation, you can use the square root property. So what is the square root property? So you've solved equations like x squared minus 25 equals 0 by factoring. You can also use the square root property to solve such an equation. This method is useful with equations like the one above that describes the race car's speed. In this case, the quadratic equation contains a perfect square trinomial set equal to a constant. So just the key concept to remind you of: the square root property, right? For any real number n, if x squared equals n, then x equals plus or minus the square root of n, right? I can take the square root of both sides and find the answer for x, and it'll give me the positive and negative answer of that square root. So study tip is plus minus the square root of n reads plus or minus the square root of n. Again, this plus or minus symbol represents both a positive and negative answer there. It represents both the positive and negative value of the square root of n. So let's go ahead and solve this equation here. So it wants us to solve x squared plus 10x plus 25 equals 49 by using the square root property. So I have take this original equation, and if I notice, this trinomial here is actually a perfect square, right? I can actually factor this to x plus 5 squared, right? If I factor this, it would be x plus 5 times x plus 5, or x plus 5 squared. So when I factor it into a perfect square trinomial, right, then it is easy to use the square root property, because again, it's just this parentheses squared equals 49. So I know that in order to solve this equation, I can just take the square root of both sides. And so when I do that, that's going to give me x plus 5 equals, remember, plus or minus the square root of 49, which I know what the square root of 49 is. That's going to give me 7. So really, x plus 5 can equal either positive 7 or negative 7. So in this scenario, I can get two answers. And so the way that I get my two answers is by writing two equations. I write the equation that x, well, if you subtract 5 from both sides, it would be x minus 5 plus 7, or x equals negative 5 minus 7, right? So x can equal negative 5 plus 7, or x can equal negative 5 minus 7. Again, both positive 7 and negative 7, right? Those are my two equations. And my answers would be that x can equal 2, or x can equal negative 12. So those would be my solutions there, right? The solution set for this problem would be 2 and negative 12. Again, you can check this result by using factoring, or by using the graphing method, or by substituting these values back into the equation to see if they actually work. So roots that are irrational numbers may be written as exact answers in radical form, or as approximate answers in decimal form when a calculator is used. So let's take a look at that. So if you're asked to solve x squared minus 6x plus 9 equals 32 by using the square root property, again, we have x squared minus 6x plus 9 equals 32. Again, noticing that this is in fact a perfect square trinomial. This factors out into x minus 3 times x minus 3, right? Or x minus 3 squared. And so again, I can use this square root property, right? Take the square root of both sides, and that's going to give me x minus 3 equals plus or minus the square root of 32. Now, if you notice, square root of 32 is not a perfect square, right? So taking the square root of it is going to give me an irrational number, right? So, but again, I can add 3 to both sides, and it would just tell me that x equals positive 3 plus or minus 4 times the square root of 2, right? Because the square root of 32 can be simplified into 4 radical 2. And then if I take both of those roots, right, one where it's 3 plus 4 radical 2 and one where it's 3 minus 4 radical 2, I can actually use a calculator to approximate those values, right? I can put this into my calculator and it would give me 8.7 and then a non-repeating decimal. And this one would be negative 2.7, again, continuing with a non-repeating decimal. So again, we'd approximate and just round. And so this would approximately be positive 8.7. This would approximately be negative 2.7. So the exact solutions for this equation are written as follows, as 3 minus 4 radical 2 and 3 plus 4 radical 2. Those are the exact solutions, right? But the approximate solutions when we round using our calculator is negative 2.7 and positive 8.7. Again, you can check these by finding and graphing the related quadratic function. So if you were to use Desmos, you could find these exact solutions. So let's go ahead and check these results by graphing. So if I took this original equation, right, and I were to subtract 32 from each side, so I get x squared minus 6x minus 23, I can go ahead and take this function, this equation, and put it into a program like Desmos, right? So I put that equation in, I can see that it makes my parabola. And remember that these solutions occur at the zeros or roots, right? So these x-intercepts represent those solutions. So again, you can see my rounded approximated answer there and my rounded approximated answer there, right? We said that it was approximately negative 2.7 and positive 8.7 approximately. And I can see that matches up with my graph. So again, that's an easy way to check your answers. So completing the square root property can only be used to solve quadratic equations when the side containing the quadratic expression is a perfect square. However, few quadratic expressions are perfect squares. To make a quadratic expression a perfect square, a method called completing the square may be used. So if our problem doesn't present itself with a perfect square trinomial, then we have to use this completing the square method to turn it into one. So in a perfect square trinomial, there is a relationship between the coefficient of the linear term and the constant term. So let's consider the pattern for squaring a term. So if I have x plus 7 squared, right? That's a perfect square there. And I were to multiply it out, right, using the FOIL method, I would get x squared plus 2 times 7x plus 7 squared. And again, simplifying, it would be x squared plus 14x plus 49, right? So this is a perfect square trinomial, right? This is its perfect square there. So here's where we want to notice that relationship. There is a relationship between this term here and the linear term and the constant. So if you can see 7 and recognize the relationship between 14 and 49, you can see that 14 is really just 1/2, 14 is 1/2 of 7, right? So if I took this middle term and divided it by 2, that's actually 7, right? That's my 7 squared that I was looking for. And if I take 7 squared, that's going to give me 49. So if you can see that the connection between the term in the perfect square and the linear and constant term, really, if I took 7 and multiplied it by 2, that gives me 14, and 7 squared is 49. So this connection is important when we're looking at completing the square. We can use this pattern to complete the square of a quadratic expression. Okay, so again, this is our term here that we're looking for. So again, we're going to go ahead and apply this in an example. So here it's saying, well, if I had x squared plus 12x plus c, what value of c would make this a perfect square, right? Then write the trinomial as a perfect square. So we notice that if this is 12x, we know that it's going to have to be like x plus 6, right? It's going to have to be our perfect square there, because we know 6 times 2 is 12, but then 6 squared is going to give us 36. So really, that's the constant that I'm looking for here, right? That's going to give me the constant that I'm looking for, 6 squared, 36. So 36 should go in for C there. So when I write that out, x squared plus 12x plus 36 would be a perfect squared trinomial. And the perfect squared factor there would be x plus 6 squared. Right, so these were the two things that we're looking for, right? We were looking to replace that constant, which was 36, and it could be written as x plus 6 squared. So you can solve any quadratic equation by completing the square. Because you are solving an equation, add the value you use to complete the square to each side. So what does that mean? So let's go ahead and take a look at an example here. So here I have x squared plus 8x minus 20 equals 0, and we need to solve this by completing the square. So I could go ahead and recognize that this is currently not a perfect square, right? Because really I'm looking for x plus 4 squared, because 4 times 2 is 8, but 4 squared is 16, and I notice that this is not 16. This is negative 20. So I'm going to go ahead and start by adding 20 to both sides. I'm kind of clear it out of the way there. And I'm going to go ahead and complete the square. Really similar to our last examples, what constant needs to be added in order to make this a perfect square? And that needs to be 16, right? Because I know it's going to be x plus 4, and 4 squared is 16. So 16 I need here, but remember, if I'm going to add a 16 to the left side of the equation, I got to add it to the right side of the equation, right? Basic equation solving technique. Whatever you add to one side, you got to add to the other side. So once I do that, then I know this is a perfect squared trinomial, so that's going to factor out into x plus 4 squared. And 12 plus 16 is 36. And now I can go ahead and use my square root property, right? Go ahead and square root both sides, which gives me x plus 4 equals plus or minus 6, right? Because the square root of 36 is 6. And then I can go ahead and write my two equations, right? So first, subtract 4 from each side. And so I know x equals negative 4 plus 6 and negative 4 minus 6. And when I solve that, I get x equals 2 and x equals negative 10. So that would be my solution set here. So again, the big technique here is completing the square by creating a perfect square trinomial, remembering that whatever constant you add to one side, you got to add to the other side, and then go ahead and follow our normal techniques for using the square root property. So you can always check the results by using factoring or to solve the equation. So when the coefficient of a quadratic term is not 1, you must divide the equation by that coefficient before completing the square. So completing the square only really works if we have a coefficient of 1, right? It's got to be 1x squared, right? So here we have 2x squared. So we can get rid of that 2 by just dividing both sides of the equation by 2, right? So if we do that, then we get 1x squared minus 5 over 2x plus 3 over 2 equals 0. And so now we can go ahead and solve by completing the square. So again, this is not a perfect square trinomial, so I'm going to subtract 3 over 2 from each side. And then again, what perfect square trinomial do I need? Right, so I could just take negative 5 halves divided by 2 and then square it, which would give me 25 sixteenths. So 25 sixteenths is what I need to add to both sides. And then I recognize that this is now a perfect square trinomial, which could be factored into x minus 5/4 squared. And then if I add negative 3 halves plus 25 sixteenths, that gives me 1/16. And then I can go ahead and take the square root of both sides, which gives me x minus 5/4 equals negative or plus or minus 1/4. Add 5/4 to each side. And there's my two answers, right? 5/4 plus 1/4 and 5/4 minus 1/4. And so when I solve those, I get x equals 3 halves and x equals 1. So again, that would be my solution set there. But not all solutions of quadratic equations are real numbers. In some cases, the solutions are complex numbers in the form of a plus bi, where b doesn't equal 0, right? And we talked about these being complex numbers or imaginary numbers. So equation with complex solutions. So what if I'm solving x squared plus 4x plus 11 equals 0 by completing the square? So again, if I use my normal completing the square technique, I would go ahead and subtract 11 from each side. And then I would go ahead and add the constant to make this a perfect square trinomial. So again, that would just be 4 divided by 2 squared, which would be 4. So I'm going to add 4 to both sides. And again, I can see now this is a perfect square trinomial. That's going to factor into x plus 2 squared, right? Because it's going to be x plus 2 times x plus 2. And then negative 11 plus 4 is negative 7. Again, if I use the square root property, I would take the square root of both sides. And here you notice that you're going to have to take the square root of negative 7. And whenever you take the square root of a negative number, that's going to give you an imaginary number. You have to use that imaginary constant or that imaginary unit. So that's going to give me x plus 2 equals plus or minus I radical 7, right? Because the square root of negative 1 is square root of negative 1 is I. And then I would subtract 2 to both sides, and I would get that x equals negative 2 plus or minus I radical 7. So that would be my solution, right? Negative 2 plus I radical 7 and negative 2 minus I radical 7, right? Notice that these are imaginary solutions. And you can go ahead and check this on a graph. If I were to take this equation, right, and put it in Desmos and graph the parabola, notice how this parabola does not cross the x-axis. There are no x-intercepts. Therefore, there are no real solutions to this problem, right? They're complex solutions, right? Imaginary numbers. All right. Thank you guys for watching, and let me know if you have any questions.